Greeting, Professor. My name is Jirukit Ryangsanti, and my ID is 6410550871. Today I'll be talking about my innovation, BrewBot. It is the yet one most modern innovation for intermediate home brewers. So why BrewBot? According to the upcoming Act of Legislature on alcohol drinks, these days people can freely brew their own beer and several types of beverage at their own will, regardless of limited place production scale, convenience, and efficiency. So first off, let me get to know the steps in brewing beer first. So the first is milling. This process starts with milling the malt barley, which involves crushing it into break open the grains and expose the starches inside. Second, mashing and lodging. The malt grains are mixed with hot water in a vessel called a mash tun. Well, this creates a liquid, now known as wort, separate from the solid grain material. Third is boiling. The wort from the previous step is then brought to boil in a kettle. During this stage, hop are particular plants that widely used to brew beer and give strong uh, sensation. These plants are added to contribute bitterness, flavor, and aromatic to beer. And boy also sterilizes the wort, deactivates the enzymes, and promotes protein coagulation. Next is cooling. Once the boil is complete, the hot wort needs to be rapidly cooled to a temperature suitable for fermentation, which is the next step. The cool wort is then transferred to a fermentation vessel. Then yeast is then added to the wort, starting the fermentation process. The yeast consumes the sugars, producing alcohol, and carbon dioxide as a byproduct, then put in the packaging. And next, it's the optional step, which is maturation. Some beer styles benefit from additional maturation or aging, where flavors continue to develop and mellow over time. This step is optional, of course, and depends on the specific beer style and desired characteristics. The main purpose BrewBot is specifically designed to automate and streamline the beer brewing process in limited scale of production, providing customization over temperature, fermentation process, and ingredient measurements. And here's a brief production lines. So we start off with uh, the electricity generated from the solar panel, which gives the power to the whole process, starting from adding malt and water and boil and boil the liquid from the previous step that is known as wort, and then we keep the boiled liquid into the cooling down tank, and yeah, of course we can add yeast in the yeast socket later, and uh, we we can gain our product. We are tap wow. All right, and indeed, this system is manipulated automatically by data analysis interface and quality controller panel right at the right side. So let's move on to the general aspects. First, the integrated control system. BrewBot's control system is powered by a microprocessor utilizing semiconductor technology. This control system manages and coordinates the various stages of the brewing process, allowing precise control and automation. And with the help of N-type and P-type semiconductors, where P-type semiconductors are crucial for the fabrication of integrated circuits, when combined with N-type semiconductors, P-type materials allow the creation of diodes, transistors, and other active devices on a single chip, enabling the construction of complex electronic systems. Second, second aspect is sensors. N-type and P-type semiconductors are used in various implementation of sensors, including temperature sensors, gas control sensors, and radiation sensors, and so on. The electrical properties of N-type semiconductors change in response to external factors, allowing the sensors to detect and measure specific parameters. The example of N-type impurities such as arsenic, antimony, phosphorus, and bismuth, these elements which contribute free electron as donors, just and the opposite is the p-type, of course, and their impurities elements are aluminum, gallium, and indium, for instance, which contribute holes as an acceptor, pardon me. And third aspect is material. In this innovation, we created the major material used to design this robot is stainless steel, as it is one of the metal alloys possessing a capability of thermal conductivity at 12 to 16 watts per meter Kelvin, which is pretty decent. Its heat conduction depends on the rate at which the electron transfer energy from one atomic vibration to another as it collides with them. Next aspect, power management. As I said earlier, the source of energy provided to run the machine is derived from the solar panel made of semiconductor materials, which typically silicon. When photons or light particles from sunlight strike the panel, they can be absorbed through the semiconductor material. The energy is then transferred to the electron inside the semiconductor, allowing it to break free from its atomic structure. Well, this creates a ETHP, or in so-called electron hole pair. The electron is excited to a higher state, leaving behind a positively charged hole in the atomic lattice. Well, to briefly explain, so the electron excited from the VB to CB. The electric field within the solar cell or solar panel, created by the internal structure and doping of the semiconductor material, separates the electron and hole, preventing them from recombining. The electric field within the solar cell guides the electrons towards the electrode, typically the N-type material, while the holes are guided towards the electrode or the p-type. This moment of charges constitutes an electric current. So the final step, to maintain a continuous flow of electrons and holes, an external circuit must be completed, allowing the electrons to return to the solar cell and recombine with the holes once again. Next aspect, data logging and analysis. BrillBot features automatic data logging capabilities, storing and analyzing various parameters such as temperature, acidity, and gravity measurements. And next aspect is the user interface. BrillBot includes a user-friendly interface such as a touchscreen display as shown in their production line, right? That is programmed to automatically input recipes monitor to automatically input recipes, monitor the brewing process, and adjust parameters by itself. The interface leverages semiconductor technologies to provide intuitive controls and real-time feedback. And next, last one is the safety features, which with the implementation of dielectric knowledge, as they are material that don't allow current to flow through, Brewbot utilize dielectric material in the form of insulating coatings or barriers to protect electrical components from moisture, condensation, and potential liquid spills during the brewing process or even cooling process. So finally, I would like to sum up the contents of knowledge I've been using. So the first one is the N-type and P-type semiconductor examples and practical applications. Next is the thermal conduction and material conductivity, and also aspect of light as a particle from elementary quantum physics, as I articulate as I articulate at the solar cell part. Next is the photo generation, where EPH, or so-called electron hole pair, is ascended from VB to CB by using photon particle. And lastly is the dielectric materials and insulation. Well, thank you for listening.